Classroom yesterday. So I know it's got 3 problems here, but I just want to go through the answers of what we did. So if you did not submit your Google question yesterday, you were supposed to, because I graded that thing, and that's going in the grade book. So we're going to talk about it. This is based on chain rule. It was an in-class activity I wanted to see, and I was grading it to see how well you did. Let's discuss the actual problem itself. So on this one, let me zoom in on that so you guys can see that a little bit better.
Did I really submit mine in the whole class one?
What?
In the class comments.
Did I actually?
Yeah.
I don't know. I didn't look. I know that you emailed me and said it wasn't showing up, so I'm like, I'm just gonna email you in the class comment like, hey, is it showing up? Because if I message you back, sometimes it kind of pops back in there. Like sometimes it's hidden in the feed sometimes for you. So I just submit it back so you
Well,
might
I
have.
think I submitted
class comments.
Okay, well that's where mine is. If
Oh,
you want
I already saw it. It came through by email. All right. First of all, first derivative, use the chain rule. The chain rule on this one, here it is. So if we're gonna do the first derivative, this is how we write it: f prime of x. It could be written as dy dx or d dx of f of x, that type of thing. I like to write it like this. I like this notation best. The chain rule is you drop the power up front and you subtract 1 off the power. It's like the power rule, right? Drop the power, subtract 1 off of it, and then the inside stayed the same. Right? Does everyone understand the basic rule there? Then you have to take it times the derivative of the inside. So the derivative of the inside on this particular problem is going to be 3x squared plus 18x. Because you have to do the power rule on the inside. So you drop the 3, you drop the 2, and you do the normal power rules on those. That's it. That's what I wanted. I know that's tough to write down in a Google Doc because you had to like type it out.
Yeah, can we never do that again? That was
It's fine. So we'll probably do it a lot more. So you'll get good at it. Okay, so the next one. So that was number 1. That's all I wanted. Number 2, same thing. This one has a quotient rule though. We have an overall rule is the chain rule. So first derivative. Okay, so first derivative on this one. We have to do the normal power rule. Okay, so we're going to drop the 3 out front, subtract 1 off the power. And so I'm going to have, x squared plus 8x minus 10. And on the bottom, I have x squared minus 4.
I'm supposed to tell you that Morgan dropped them wrong.
I don't need to know this. All right, so we do the normal power rule, drop it out front, subtract 1 off the power, and then we have to take it times the derivative of the inside. Now, this is the part that a lot of people were struggling on yesterday is like, how do you write it? Here's what you have to do. The derivative of the fraction is a quotient rule. So this is the derivative of the inside. It's 2x plus 8. That's the derivative of the top times the bottom minus the derivative of the bottom times the top. Shh. All over the bottom squared. So that's x squared minus 4 squared. Okay, so that's the actual derivative of the inside. It's a quotient rule. That's a nightmare to type. I know that. You're using a lot of parentheses on Google, typing that in. I'm just looking to see, did you have the generic setup? Do you know how the power rule works? Do you know how the quotient rule worked after the back? Okay, now, the homework that was due on Wednesday, last night, that was all quotient rule stuff. The homework we're going to get tomorrow is all chain rule. But we have to get to the new rules on it, okay? But that'll be tomorrow's. And, oh, now you're getting home. And it's not going to be fun now. So, all right.
Hey, sorry, guys.
All right. Okay, bottom problem, number 3, on this one. This is not your Google question of the day. First derivative of this. So doing the power rule, we have to drop the power up front, subtract 1 off the power. All right. So, is there any questions with how the power rule worked on a trig function? Now, when we take the derivative of sine, like the inside, right? The sine is the inside of function. The outside function is the power. The inside function is sine. The derivative of sine is cosine. So x squared plus or minus 4x plus 3. All right.
Wait, hold on. I get how you got that first part, but how did you get cosine?
because that was one of our new rules that we talked about on, I think it was like Tuesday. The derivative of sine is automatically cosine. That's like one of the we're going to review those rules today. Like derivative of sine is cosine, derivative of cosine is negative sine. We'll talk about tangent today. We're going to talk about e to the x, and also like 7 to the x power. We're going to talk about those rules today. Okay. So like specific ones, you just kind of have to have them known, memorized. So yeah, that was a problem. I think that was Tuesday when we introduced that.
That's what we're doing today.
And then the inside, we're still not done yet. So that was derivative of sine. And then we have to still take the derivative of the parenthesis, which the last step is 2x minus 4.
So it's not cosecant?
For sine? No, that's a reciprocal. It's not the derivative.
Okay, so yes. So reciprocal is not the derivative.
Not a derivative. No. And we're going to talk about those rules. That's the next slide we're going to talk about, the specific
So you
rules.
had to take the derivative of the derivative of sine. Of what's in that parentheses?
Yeah, because the outer rule was the 7. The inner rule was sine, and then the inner rule of that was the parenthesis that was on the sine.
Which is 2x.
Which is the 2x minus 4. Yep. All right. So let's do the next. So again, these were the Google questions of the day yesterday. That's what you had to submit yesterday. And I know it was kind of a nightmare typing. All right. So now on this slide, this is the second slide out of 3. We need to talk about the rules. So this is the part that Mr. Heckmiller just talked about a little bit ago. How do we know like what the sign of like sine is, or sorry, not the derivative of sine or the derivative of cosine? These are the specific rules I want you to know today. And then the next slide, we'll just put one into practice. Okay? So here's the rules. Number 1.
I really hope they're just secant, cosecant,
We can't see
sine,
that.
cosine, tangent, cotangent.
Thanks. So, they're actually pretty straightforward yet, so we'll talk about it.
There we go.
There you go. Nice.
That's weird. I had to be in a very specific spot for that to work. Or not. Okay.
I thought you did that.
I thought it'd be a little more.
Is that Wyatt?
Yeah, it should be.
Why is this so weird?
Hmm?
Why does this not say Wyatt?
You didn't put the name in.
Yeah, you can rename it. Yeah.
Okay, so what app do you use for this word?
For what?
To do this, because this isn't your normal notes, is it?
Yeah, it's my normal notes. It's Notepad Plus. That's what I use. So.
Sometimes he has lines, sometimes he doesn't.
Yeah, I can pick the type of paper. I can pick grid paper. I can pick line paper. I can pick white, off-white. I can pick musical note paper, like with the lines for notes.
Is your off-white like 90
Can we
off-white?
do the
or
music?
is it just,
It's like eggshell color, and it's got kind of like a weird, like you can see a pattern on it. So, we'll pick it later. So, because I can't do it right now since I'm already started one. So, all right. Okay. So the rule number 1: if we take the derivative, d dx of sine. So the derivative of sine. This is one of the rules that Heckmiller, you were asking earlier. The derivative of sine is cosine of x. That's the derivative of sine.
We should put rules of, like, what is it? Like, what do you think?
Rules of chain rule?
Now, rules of first derivatives. These are special cases, maybe you want to put.
You get like third and
In
fourth
parentheses,
derivatives?
put special cases.
Sure.
Special K.
Hey, you know he didn't teach PE. I guess I never had to.
Okay. Okay, second rule. Second rule, if we take the derivative of cosine, the derivative of cosine of x, that's negative sine of x. So that's the one that you got to remember. If you take the derivative of cosine, it'll be negative sine. Okay?
What's d over dx?
That's derivative. It's derivative with respect to x. That's what they call it as.
Respect to x?
With respect to x.
So it doesn't just go back to sine, it's negative sine.
Yeah. Yep. Yeah. We'll explain later. That's like the next section, like the last section of this unit. Will, like when we look at graphs, it kind of makes sense when you look at the graph of that. You're like, oh,
right now I'm
okay.
thinking derivative of sine is cosine, that makes sense. But
And then you'd think you just go backwards. Yeah, it doesn't. No. Okay. All right. And it comes down to graphing. All right. Number 3. Okay. The third graph, or the third derivative. Derivative of e to the x. E is that natural number. It's like 2.71, blah, blah, blah. But it has an x for an exponent. The derivative of e to the x is just e to the x. It's just itself.
Oh, there's another one?
I like it.
Yeah, super easy.
You can deal with that.
Well, and that's the one I'm going to use today. I'm going to use that as one of my examples. And then the next one, this is the fourth one that we're going to look at today. We have 5. The next one is the derivative of any other number. Now I'm going to call it like a to the x. A can be any number you want. Instead of e. E is like that natural number, 2.71, blah, 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 blah. But a can be any number, like 8 to the x, or 9 to the x, or 2,000 to the x. Whenever you have a derivative of some constant to an x power, it's going to be the natural log of that number times a to the x. So we can do one of those.
ln times a.
ln of a, the natural log of that
So
number.
you just click
You-
natural log.
natural log, hit the number, type it, it'll give you like some decimal on your calculator.
So the derivative of e is e.
Yeah, derivative of e is e. It's just the same thing, it just stayed.
So d over dx
Yeah, you would
is
know.
just.
So why
Okay.
Well, I
wouldn't
just
A
did-
also be all the other problems we've been doing up until now? Or no?
No, it'd be a little bit different. So
Because what?
this is when you put something to an exponent, like a variable in the exponent. It's not like 7x, right? It's 7 to the x power. That's a difference.
There's never code to show.
Okay, question.
So then, on that, their calculator on that poster, you just press ln, type in like a, which would be 2,
Yeah,
and then 2 to whatever power
Yeah.
it is. Okay.
yep. Okay,
So there's two big math numbers, pi and e.
yeah,
Those are the big ones?
yeah.
Is there any line?
Not that I know of,
How do
that I use anyway.
How do I get that down?
Is this for Sam?
No, no. Okay, all right,
Maybe he's
number 5. Okay.
He's like 6'7".
Okay, number 5. This is the last one for us today. All right, dx of tangent
He's tall.
So
Of
that
X.
was bad.
So tangent of x. Tangent of x is equal to 1 over cosine squared of x. 1 over cosine squared.
See, that one doesn't make any sense.
That's what I actually want to talk about. That's the one I want to go through on the next slide. So I'm going to make up a problem on the next slide and we're going to kind of walk through it.
Oh no.
Okay, so these are the 5 rules that I want to discuss. There is more. I just want to introduce these kind of basic ones that I use quite a bit in Calc 1 and Calc 2 that I remember using. These are the ones I used a lot. And then eventually there is more. They teach you like secant and cosecants, all those. I usually just wait on those until we get all the basic rules that we need. So,
$5.
all right. Okay, all right. Let's go to my last slide of the day. This last slide. Hopefully you have those written down. I can go back and I'll take a screenshot of those and put them on the website. Okay, so here's my last slide. We're going to take the derivative of tangent of, let's go, e to the 7x. This is my last problem. This is the one that you have to submit on the Google form question today. This is a chain rule. So that's why I bring it up. It's the overall function on the outside, and then we have something on the inside and something on the inside of that. So it's like a chain rule of a chain rule of a chain rule.
No.
It looks so not dangerous. But
Yeah, but when you look at the derivative, you're like, wow, there's like a lot to it. So, okay, so the outside rule, what is the outside?
Tangent.
Tangent. So what's the derivative of tangent? We just talked about it a little bit ago.
1 over cosine squared.
1 over cosine squared of whatever was in the parenthesis. Agreed?
Oh,
So whatever was in the parentheses stayed there, right? It's because whatever tangent was, that parentheses stayed. Now we have a times symbol behind it because it's a chain rule. So now we have to take the derivative of the inside. Well, what was the derivative of the inside of the parentheses? What's the derivative of e? It's e to the 7x, right? Because the derivative of e stays e. But then that had something inside of it. And that was the power, right? The power that's on the e, we have to take the derivative of that because that's in a parenthesis. So what's the derivative of 7x?
7.
7. Done.
What? That's all I have to do?
That's it.
That's not that bad.
Not bad. Now,
You just wait.
okay, that's what I want in the Google form question. Now, I don't know how you want to type that. You got to just type that in. Now, I want to talk about why did tangent turn out to be like 1 over cosine. So that's what I want to discuss. I'm going to put it on the bottom of this slide, but this is what I want you to enter in Google right now. So go enter it. I'll give you 2 minutes.
That is not enough time.
Oh, you better.
I had to play God yesterday, saving pigs.
I heard. Good work.
Well,
Yeah, they get a little feisty. Sometimes just something gets in their head. They start picking on one, they smell blood, and they just start going
yeah, I
crazy.
think it squealed weird because I
Yep.
may not have given a feed as early as I should have given a feed. And then
Yeah.
they started picking on it. But now they're dead
It
anyway
happens.
because we loaded them up this morning at 5.
Oh, and they just kind of froze? Or
No,
they, or they
no,
got
they didn't.
slaughterhouse?
We loaded them up, they got slaughtered.
Oh, okay.
My dad used to have me play God with the pig when he had hog buildings.
Only the opposite.
The
way.
sick ones just bam.
I was playing doctor, you were playing God.
I was playing God.
Okay. All right. Again, for all those online, this is the Google form question that you're submitting. It's the, what is the first derivative of that 3rd example? This is it. This is the one. Now, I'm going to draw a line on this one here in a minute after you guys get a little bit of time to submit this on Google. I want that. You're going to type it in, use brackets, use parentheses, use whatever you need. Now, after we're done here, I'm going to draw a line, and then I'm going to just talk about why is tangent 1 over cosine squared? Because I heard it earlier. It's like, wow, that's really weird. Like, why did it turn into that? I do want to discuss that.
We'll try pressing it multiple times.
Don't worry, Ward, I'll get this figured out. I gotta figure out how to type it first.
Yeah, I know. That's the hardest part about this stuff is typing it in.
So much easier to do on your phone. Keyboards are hard.
Help me.
2.
Yeah, I wish I would have figured the phone thing out before I did.
Again, a reminder for everyone in here. We're probably looking at a test at the end of next week. So probably what I'll do is I'll probably print out the practice guide for you guys and have it in your hands tomorrow. That way, because I won't see you until Thursday next week. So I want it to be in your hands. So you have it. We'll do the review on Wednesday and Thursday next week, like we always do, and then Friday will be our test day. It'll be some basic stuff about first derivatives. We have to go back and kind of review. So there's quite a bit of stuff we have to go back to. It's about the last 2 weeks of our stuff
How
here.
are the people on Monday, Tuesday going to do?
So I'm trying to figure out if I can get them to come in, like if that's possible, just for 1 period. But if they can't, then they're gonna have to take it online, and I'll just like. So no. So what I'll have is I'll just have because I'm gonna have multiple versions of the test. So I'll probably have I'll just have the test for them shared with them, just on the screen, and then I'll just watch them take it at their desk at home, and then they'll just take a picture and send it back to me immediately when they're done. So.
You can't put them in a detention room or something?
No, that's what I want to do. Is well, if I'm taking a test, can we just bring them in for that period? They're in a separate room. Nah. So, I'll talk about it. So.
Ward acted like he was giving me $1 million when he let me come in on Tuesday to go. I'm like, well, thanks, but it's because I want to figure out my school that you wouldn't let me go to for the past 2 weeks.
Okay. Anyway. Okay. Let's walk through why tangent turns out the way it does. Okay. So that was the Google form question. I'm gonna put a little star next to that one. All right. Let's talk about tangent. I want to talk about why does it work out to be the weird thing that it is.
Can we just kind of absorb this?
Yeah. Just absorb. Just watch. Okay. All right.
Nasty brother.
Okay, tangent. If we look back at all the rules that we did back in pre-calc days, we had all those trig identities where there was things you could substitute in that were the same thing. They were just written differently. Tangent can be written as sine over cosine. That gives you the same value on a calculator. Sine, or whatever the angle is, divided by cosine. Those were called the trig identities. They're on that piece of paper that I provided you. This is one of them. And this explains why the derivative of tangent turns out the way that it does. Because when you actually take the derivative of tangent, right? Taking the derivative of tangent, it is the same thing as taking the derivative of this fraction. Well, when you take the derivative of a fraction, you do the quotient rule to it. So derivative of the top times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. So let me walk through that. So derivative of the top. So let's go through the rules. What is the derivative of sine?
Cosine.
Cosine. Okay, good. Now we take that times the bottom. minus the derivative of the bottom. What is the derivative of cosine?
Negative
Negative
sign.
sign.
Negative sine.
I'm so stupid.
And then we take it times the top.
I don't even know.
And then this is all over the bottom squared. Okay? And what happens here is that the top, the numerator here, will actually turn out to be cosine squared, x, because it's cosine times cosine. And then we have a plus sign because these two negative signs make a plus.
The sign's
And then we have sine squared. And that was one of our Pythagorean identities.
over cosine squared.
Over
So the
cosine
answer
squared.
is sine squared.
Not sine squared, but the answer is going to be a 1 on the top because that cosine squared plus sine squared was one of our trig identities. It was one of the properties we had in pre-calc where you could substitute things of equal value. The trig identity for cosine squared plus sine squared was 1. It was like something we substituted. It's called the Pythagorean identity. And then on the bottom you have cosine squared.
Yeah, we definitely didn't get to that.
Yeah, we did. It was chapter 4 and 5. It was like right. It was right before the pandemic.
I like
Weird.
to remember
Weird.
it. But like,
It was a long time. It's like February, January timeframe. So
All right then.
yeah. Okay. What's up?
Tell Isaac he's dumb because I remember it.
Tell
Hey,
him
I don't remember it, Eric. Okay.
They can hear you just fine. So, okay. Okay, but that's why it works out the way that it does.
He's arrogant for me. Thanks.
All right, but there you go. I want to explain why tangent turns out the way it does. I usually don't do this. I usually wait till that third chapter, but this one was just kind of a basic one that if you remember some of your pre-calc rules, that one's simple. It's not like where we have to look at graphs. Okay, tomorrow. We have homework tomorrow. It'll be due probably on Tuesday next week. It'll be a worksheet. It'll be probably 5 problems with chain rule. You'll just do the work on a piece of paper, take a picture, submit it on Google Classroom to me. I know a lot of you like to turn in a physical copy. I want it submitted online as well. So that'll be online tomorrow. I'll try to give you a physical copy tomorrow of your practice guide, but that's something that, again, you'll have to turn in on Google Classroom. Okay, so that's going to be coming up for next week. We're going to review. Next week, we're going to start on Monday and Tuesday. We're going to do the last section, which is graphing. It's just the last thing. It actually explains why tangent and cosine, or sorry, sine and cosine work out the way that they do. So we're going to look at that stuff. That stuff is the section I love to end on. The last year's class really liked the graphing part of it. They thought it was easy. It was kind of fun the way that we draw stuff. But I definitely had people in years past that did not like it. Just because they can't see the simplicity of it, like how simple it's supposed to be. Like it's way easier than you think it
I already
is.
know what kind of person I'm gonna be.
All right, but that's going to be up for next week. But tomorrow we're going to review this stuff, chain rule. I'll review all the different rules, like especially like that a to the x rule. I want to walk through that one tomorrow. I would expect in class we'll probably do about 4 simple examples, and then I'm going to turn you loose on a chain rule problem. Okay, worksheet with 5 problems on it. Okay, questions with what's coming up tomorrow?
What's our COVID percentage?
24 point something.
Let's go.
So, yeah, something like that. All right. Okay. All right. If you have not submitted your Google question of the day, it's at the top. It's this part right up here. I'm going to highlight it. This is the part you had to submit to me on Google Classroom. This is the answer. So make sure you submit that for the question of the day. If you have not submitted yesterday's homework, it's late. Turn it in. Question.
So, on the assignment that we have to do, that would be like one of the answers, like that whole thing right there? We
Yeah.
don't have to simplify or anything?
No, you can just leave it like that.
No, it's like
Thank
before
you.
that.
Okay. All right. But that's it. So.
Something about today, Travis. Has he done
Oh gosh, I don't know why.
Is
the
it
blood
out?
flowed
Are we good to
today.
go, Ward?
Yes, you are. Yes, we are. We are going to be taking the test on Friday next week for
I
sure.
love the Corona
So.
Flintstones.
Alright, let's see your words.
games.
Yep.
Me too. Kids. That
So, Erica, did I answer your question? Yes, we are taking it on Friday next week. Sorry. Definitely on Friday, not just like I'm giving you a random date. It is Friday. So,
It's gonna be so nice after we get done with our like college finals that we're gonna have like a lot more free time.
yeah. Okay.
Oh, Ward. I have to play chess every day for 30 days.